Okay, hi, Randy McDonald. Randy McDonald. If you watch my first video thing, this is going to be a series of articles on dark matter and galaxies span cores what I know about them. And I realized that I can actually give my little wish list of things that I want to know from the data that I already got, and kind of go in a little bit more detail of what I think where I think they are and how I think it'd be used. I know I'll probably ramble on a little bit, but what the hell? Yeah, I can make it minutes if I want. Anyways, to start off with, dark matter, a galaxy is spinning core. What that means is the core, which is a giant black hole in the center of the galaxy. Usually, in between expansions, it sits suspended in a chamber surrounded by a star field in the center of the galaxy, and we know it's a black hole because there's a dark spot. If you take the galaxy, a picture of it in a galaxy, here's a plane, cut in half here, cut in half here. There's a dark spot right here. That's the hole where you can see into it, the inner galaxy, and see part of the black hole. And so we know it's a black hole, and when it starts to expand, it means enough matter has been drawn in from the plane to get close enough that the black hole starts feeding on it and consumes most if not all the matter in the chamber to a certain point. And it doesn't start doing this until it gets, I believe the layer is like 2,000 light years high and stretching back around 10,000 light years, completely surrounding the core in the chamber. And of course, dark matter, there is a core of matter in a galaxy, or for what I was going by, but that's kind of a misnomer because the amount of matter in the inner galaxy compared to the outer galaxy, if the Earth was in the inner galaxy, we'd have potential sunlight all day long because the stars would be close enough to cause as much light as you get after about dawn or about after sundown all day long, even in the middle of the night. So core of matter there is actually a core of matter, a larger amount than the core of matter out here in the outer galaxy. So when we talk about huge amount of matter and huge amount of dark matter, and dark matter is of course a heavy matter. Heavy matter, small pieces of matter, heavy matter from supernovas forming nucleus of planets in a forming solar system are weigh about 1 billion tons. Piece of dark heavy matter from a supernova the size of New York City would weigh as much as the Earth, so a piece the size of a baseball would weigh about 1 billion tons. Kind of simple process how it does it. You got a large gravity well, small object. Gravity well stronger and can fill more. The object, when it fills to the point where you'd have a 1 billion ton object, you'd have 2 billion tons of hold, a 2 billion ton gravity well that extends further out, and it's stronger nearer than what was, and of course, a billion tons in an object the size of a baseball has a lot more pull in that area. It's kind of like a stronger magnet. If you have a magnet that comes 400 square feet with 100 pounds of pull, you don't have 4 pound pull per foot, and if you have a magnet the size of the tip of a cigarette, you'd have a hard time pulling that off. Basically how it works, and since that's impervious to being destroyed because it will just reform even if it's broken up. Once you get heavy matter in the right environment, it's going to form a planet or a star. Which the star that has some black holes, one of the stars going through when they pass the nebula, basically do the same thing. And those stars get blown apart several times before they reform into a stable star. So, yeah, it's pretty much indestructible. But as black holes, they're weighing tons per atom, many tons per atom. So you got something about the size of a DNA strand or a not too big molecule, nowhere near the size of a single cell organism to make 1 billion tons. And dark matter is not near that heavy. It's still in the range, I believe, where you'd be able to see it if dark matter wasn't visible. And when the core expands, most matter doesn't go into expand the core and make it bigger. Most matter is shot out of jets out of top and bottom in a dense state, travel at a high rate of speed, or a small area. I believe it's 70-some%. And as far as dense state. It's not as dense as what enough to cause nuclear fusion, but it's way denser than what Jupiter can produce. Relatively small area. We're still talking hundreds of light years across, and high rate of speed. When it comes off the core, it's traveling at the speed of light, and I believe when it emerges from the star field surrounding the core into outer part of the galaxy or into space, regular space, it's still traveling about half the speed of light. So that's fast. Now, when it comes off the core, it's not only traveling at near the speed of light, it's also spinning at a tenth the speed of light, which creates a giant, super powerful centrifuge. A centrifuge separates matter out by weight, and all the matter in that layer is going to be absolutely pure and of one type. So it's going to be absolutely pure. And again, we're talking about density that can't be created. Jupiter can't create, and the layers are going to be the heavier matter is, the further out on the jet is going to be. Which this will be on the outside because of the heavy matter. So and the thickness of the layer, we're talking hundreds of light years across. So we're talking light year around that of a dense, pure heavy matter that weighs more than billion ton of baseballs. This thickness is measured by how far light travels in a year. It's a hell of a lot of weight on the outside. Now, in the inner chamber, there's a huge amount of pressure, so there's pressure squeezing in on the jet, squeezing it together, and when it leaves the inner galaxy, star field surrounding the inner galaxy, the chamber, there's a release of pressure instantaneously. To understand this, what happens if you had a stream of water in a hose that was under high pressure, going at a high rate of speed, and you had powdered lead or something as heavy as lead in a liquid form. It's what would happen. What happens when the lead water reaches the end of the hose and comes out, and there's a release of pressure. The lead comes off because the water doesn't have enough gravity to overcome it spreads out a little bit. There's a little push out, so the stream of water just gets a little bit bigger and continues on the same direction. But the lead, because it has so much weight, it comes off at an angle. Oh. Basically, that's what dark matter does. Same principle. Its weight has enough that when that little push out changes its trajectory and it separates, or almost all separates. Which fortunately for us is going at the right speed, at the right angle, and it separates the right time, and it is at the right weight to achieve a low orbit above the galaxy, low enough that the gravity can cause fluorescence. If it was a billion-ton baseball weight, it would go off at an angle. Still go off at an angle, it would separate, but we won't be able to detect it because even though it's dark matter, and even though it's in a pure dense state, and there are huge amounts of it, dark matter is still invisible, producing no light, no heat, no radiation, no electromagnetics. So it's undetectable as matter normally. So unless you was looking for, all you would see, the only way to see it is if there's distortions, and if it was weighted billion-ton balanced black holes, it would come off and it would achieve a low orbit and then crash into the galaxy, and you actually see a black area surrounding it. And the fluorescence is not as much as a black hole. I mean, it's a huge amount of weight, but it's a cumulative amount of weight. Kind of like the air column of air causes the air pressure on Earth. Now, the fortunate thing for us is the jet is not completely covered when this happens. It starts off at small amounts, which gradually increase until areas cover it, and until the whole jet is surrounded, and you get a heavy flow of the dark matter separating. Now, my brother-in-law John Baer kind of helped with three things. He looked at pictures of these inner galaxies. That's points where I was looking at, and I'm going to be talking about the pictures in sequential order. He he didn't show me them in sequential order, and he refused to put them in sequential order. Which you understand why when I tell you some of his reactions here. And so if somebody could put them in sequential order for me as you watch this, so people can see what I'm talking about and see it actually happens, I'd appreciate it if anybody listens and bothers to do it. And he also gave me two other pieces of information. I kind of go over the last one because that's the big one on my Christmas wish list for data that I would like to get off of it. How I'd like to use that data and what information I want to get off of my Christmas wish list. Might go on a little bit on that. But anyways, my brother-in-law showed me pictures where there's bright stripes near the jet, near where the jet was coming out. There's few in number and not too far from bright stripes, not too far in distance from the jet, and there's that varying length, so there's apparently had separated at varying time. He showed me other pictures of galaxies where that had increased a little bit in number and distances, still varying. Then others where it had actually increased substantially, and some of the jets had actually reached the plane, and a point just above the plane, which seemed to be consistent. All the ones where it reached the plane, it began to rapidly expand into a gas. You could tell that by the fluorescence, and the gas expanded so rapidly that it changed directions and started moving out above the galaxy at a high rate of speed. And I knew it was a heavy matter gas because only a heavy matter gas would have enough gravity to produce fluorescence, which is an effect caused by gravity that is visible with the naked eye. That's heavy matter. And then there's other ones where they had increased, so where more stripes were reaching, again all uniform. Then a sheeting where part of the galaxy was covered like water flowing out of, or wax flowing out of a candle, was increased. Again, all the flood still separated, still turning to gas at the same time, until the other ones were you could only see small parts that wasn't completely covered by the fluorescence, and then others where the whole fluorescence covered the whole area between the plane and the jet, and you can see to get this heavy matter gas, I believe the heavy matter gas, moving out away from the galaxy at a high rate of speed. Well, that all fit, and that was what I was looking for and should have been doing. So I go to my brother-in-law, John Bear, and I go, "Hey, John, I think this is what I'm talking about, but I got some information, wanted some more information about it." He goes, "Well, this can't be dark matter because there's nothing causing it." I'm like, "Well, John, that's what I'm looking for, because even though it's dark matter in high concentration and pure form, it's still dark matter, so it's still invisible, produces light, no heat, no radiation, no electromagnetics. That's what I'm looking for." It took me about 10 minutes of telling him that the fact it wasn't no detectable matter was what I was looking for, and having him actually talk about how dark matter was undetectable before he finally realized what he was telling me wasn't disproving my theory, but was actually information I wanted to hear. And when he did that, he goes, "Well, I think you're wrong. Because smart people have probably already thought of what you thought of. The smart people have checked into this. The smart people have discounted this because smart people aren't saying this. Smart people don't know what that is. I don't know what that is because smart people don't know what that is. And you should listen to smart people because they're not saying what you're saying. But if you want to prove that heavy dark matter, you got to come up with a hell of a lot more proof than that." Yeah, that was the least abusive he got. Now, he did give me some information, which I'll go over and kind of touch on a wish list because my time's limited. But after I was talking about the effects of dark matter, if it was flowing out the way I said, what the effects were, and one day I went over to his house. He set me in front of a computer screen, and he saying that he wanted a detailed scientific analysis of what was going on. There's a picture of close-up picture of the edge of fluorescence in one of these galaxies, and he said it was at the halfway point, and he was going on about how information scientists have been able to come up with. And he wanted a complete scientific analysis. But he gave me 10, maybe 15 seconds to look at it. And then he starts going on about how I'm not a scientist, so I couldn't come up with it. A real scientist came up with this. He goes, and a real scientist came up with this off of the effects of the gravity on the galaxy. And I'm like, so there's no detectable matter there. He's going after the gravity, but he's got detected matter. He goes, well, yes. Oh, yes. I was like, okay, that fits. He goes, he said it was so many space term high with so many space term wide and so many space term long. And he was going about how huge that was. Like, how huge is that? What does that mean? And he goes, well, if you was a real scientist, you'd know that, but you're not smart enough to be a scientist, so you don't know that. And I was like, well, can you give me a clue? Is it a light year or more? Or less than a light year? He goes, it's more a light year. Found out later that it's 3.5 light years, and it's talking about four of them. So we're talking about something 16 light years high, 16 light years wide, 16 light years thick. Or long. So we're talking a huge area. And he goes, and it has a density in some space term I didn't understand per other space term. And I'm like, what does that mean? How dense is that? Because he was talking about how dispersed that was and how little matter there was in that area. And I was like, what does that mean? How dense is that? And he was going, it's not very dense at all. And I go, so it's consistent with a gas. He goes, yeah, but they're not saying that, and they're smart enough to come up with that, so they're right, you're wrong, and they're not saying it's gas. I said, but it's consistent with a gas. I said, how dense is that compared to our atmosphere? Is it as dense as what we have here on the ground? He goes, no, not anywhere near that. I said, is it up in our atmosphere? Oh, yeah. And I go, well, how high up in the atmosphere? And he's like, if you was a real scientist, you'd know that. You're not a real scientist because you're not smart enough to be a scientist. I'm like, okay. And he goes, and it wastes so much space term for a space term. And I was like, and he goes on how heavy that is, incredibly heavy that is, and how it's something that's dense shouldn't be able to cause that. And I go, well, what does that mean? How heavy is that? Is it? And he goes, again, well, you're not a scientist, you don't know that. If you did, you know what I was talking about. Well, you're not smart enough to be a scientist. I said, okay, is it heavy enough to be a heavy matter, apparently? And he goes, well, yes, it's definitely a heavy matter, and a real heavy one, heavy matter. And it says right on the edge of fluorescence. He goes, yes. It said, is it enough to cause the fluorescence? Well, yes, easily. And I was like, okay, that's what I'm looking for. He goes, it's traveling at so much space term for a distance for so much space term for time. I'm like, how fast is that? And again, he was going off how I was a scientist. If I was smart enough to be a scientist, I'd know that, and he knows what it is. I said, is it traveling as fast as the fluorescence? And he was like, well, yes, it's traveling the same speed as fluorescence. Now, you know how that far that is in the speed of light, don't you? Tell me right now and be exact. And I was like, okay, John, this seems to all fit with what I'm talking about. He goes, well, you're wrong because scientists aren't saying that's dark matter, and scientists aren't saying what you're saying about it. So you're wrong because they're smart enough to come up with this. You're not smart enough to be a scientist. And I started to tell him about things I wanted to know and how it related. And at that point, he got abusive and aggressive. At that point, he was nowhere near as abusive as he got when I started talking about how we could use this. But this is how I think I would use it. We got a known area with a known density with a known weight. Now, I know there's distortions in the galaxies to the point where they barely get any usable data, and I'm pretty sure that's going to be causing distortions. Distortions like heat waves coming off of a hot object. And dark matter in high enough concentrations causes distortions within everything you look at it with. The higher the concentrations of dark matter, the higher the concentrations of distortions. And we have a known amount of something that I believe is dark matter, causing fluorescence just like coming out of jets. So if we get the amount of distortions it's causing, and then check along the edge where this is found, that it's known to be found at the halfway point, and see if there's consistent weight and everything, consistent distortions, so we get consistent, if it has a consistent amount at that point, and if it has a consistent amount of distortions. Look a little bit ahead of it to see if there's a cloud of distortions that are lesser, that like a gas just off the edge, and how far out that would go until you get clear data, so you get the amount of distortions. So we got a baseline of how much distortions per weight, per volume, per area. Then go back to the jet, or the jet where the stripes are coming out. When they first appear, check how many distortions there are. There should be a huge amount of distortions in that small area, with some coming off the periphery, a little bit to the sides, that should be dense enough that by known amounts to cause fluorescence. But there should be a huge amount there. We should be able to get the weight, possibly the density, or the weight and the amount, and possibly the density. It might be able to get the height by using the distortion data we can get from the useless information John went on about. We should be able to get that. Now, I mentioned that the stripes turn into gas about in a uniform area. What I think, this is hard to believe, I think it's a liquid when it separates from the jet, because of the way it turns into a gas. Yeah, and I think, for lack of a better term, it's steaming. So there's steam coming off of it, which there should be distortions coming off of it in small amounts that are detectable, which should increase as you travel down towards the plane. I think it's enough of it steaming off that loses enough gravity in that area for it to no longer be able to have enough gravity to remain as a liquid, and that's when it explodes to gas. Of course, the presence of the gravity from the plane probably has something to do with that effect. But since it's uniform, it appears to be a uniform amount of steam coming off of it. It's the uniform amount, which we can get that with the distortion data. Now, I mentioned that not all the dark matter separates from the jet. I've heard from scientists over the years that when we're studying these galaxies, especially a jet, they get clear data for quite a bit of time. Then they get something interfering in spots with the data they're getting, something interfering with it, something distorting it. These increase in area and amounts until they completely cover the entire jet. After that point, they don't barely get any usable data, if any usable data. What I'm thinking is that where the stripes are, there should be a corresponding area of distortions on the jet, and roughly the same area, roughly the same height, and the same amount, and they should increase an almost mirror image to the area of fluorescence on coming out of the jet, where the dark matter residue is separating. And since we have a baseline of how much distortions this amount is, we can tell pretty much how thick it is and how dense it is of this residue. That's really big on my Christmas wish list, because this is a continuously flowing amount canvas, so it's always changing. So you get precise data on how much dark matter is separating by studying the jet. Once you get the data in, and see whether it has a fading effect over distance that stays consistent over the period, so you can get real accurate data. Because like I said, the steaming, there may be a residue that builds up, and if it's not consistent amounts in the jet, distortions in the jet, it may skew your data for doing any research on distortions coming out of the jet after that point. So you have a crisp, clean, continuously running photographic record of the entire separation of dark matter from the jet. And I'd kind of like that real big for my Christmas list. And next article, I'll go into detail about this known area and where I would like to know where it's at and what I believe that would mean. and what we need to do, and it's a hell of a list. And probably should have been. I was at this point since 2006, so I probably should have contacted and somebody about this, and this work would have been done. But there's a hell of a lot of work of what we got to and do, and but I'll try to be as short as possible, So that's where I'm at Dark Matter on this point. I hope I haven't bored you. Bye.